Hey everyone, welcome back to part 8 of topic 7 in our database class. In this video, I'm going to discuss additional considerations and guidelines for using database indexes. And on a personal note, I will mention that this is the final video in this series. So if you've been with me along this entire journey, you've now watched more than 80 videos, and I sincerely hope that you now feel much more comfortable and knowledgeable about database technologies. All right, for one last time, let's get started. So, some considerations for using indexes. Right now, remember that whenever you create an index, you are storing additional information. And that means that, hey, if we have, a very large table that we're indexing, potentially our index could use lots of storage space. And with that in mind, we typically will want to selectively choose columns to index, right? So this means that as a database designer who's designing an indexing strategy for the database, we need to have some awareness of the types of queries that are commonly being run against this database. Okay. So with that knowledge, we should be able to identify, common queries that might benefit from having some indexes. Okay. So just awareness of which like SQL select queries are actually being run in this database. Right. An additional consideration for using indexes is that if we have a table that is updated frequently, by which I mean that the data in the table are frequently changed, either by adding new data, deleting existing data, or updating, changing the values for existing data. In those kinds of situations, we need to think very carefully about whether an index should be implemented. The reason for this is that every time a change is made to a data table, the index needs to be rebuilt. And so we need to rebuild the index. In that rebuilding process, if we add a new row, delete an existing row, update a row, that rebuilding process takes computational time and effort. Right. So if we have, say, a lot of indexes on a table that is updated heavily, updated frequently, then our goal of using indexes to speed up query performance may actually turn out to work against us because all of the additional work that the database needs to do in order to keep the indexes up to date may actually slow the overall performance of the database. Hmm. So we have to kind of judge and make decisions about using indexes intelligently. And we have to have some awareness again about how these tables are being used. Right. So we should certainly be sparing in our use of indexes on heavily updated tables. All right. So just some guidelines that'll give us some insights into the use of indexes. Yeah, again, be sparing with your use of indexes on heavily updated tables. If you have a situation where you need to be able to generate, say, I don't know, reports and things quickly related to a heavily updated table, it's typically better to set up some sort of, data warehousing architecture where we pull all of the data out of the operational database on a periodic basis, maybe once a day, once a week, whatever it may be, and dump those data into a data warehouse. We can then, you know, index the data warehouse to whatever extent we need because it's offline, right? It's not being used to run the real-time operations of our business. So it's fine, if we make the database do some work out there to, build databases and so on, because with the data warehouse, we would only be updating those data infrequently. Okay. So in that case, we can still achieve an improvement in performance. It's just we would have to trade off not having, totally up-to-date real-time data. Instead, we would load, the data into the data warehouse on a periodic basis and then use the data warehouse as the basis for conducting our queries, getting our answers. Right? On the other end of that spectrum are tables that are updated rarely. And if a table is updated rarely, and if you can spare the storage space, which shouldn't be much of a consideration these days because disk space is very, very inexpensive. In that scenario, please feel free to add as many indexes or, as many index columns as you need in order to achieve maximum query performance. Okay. So again, if our tables are updated very infrequently, then there's no reason why we should have slow performance, right? So as long as we can spare the disk space, we can implement as many indexes as we need to achieve maximum performance when querying that table. For clustered indexes, we know now that they are typically constructed by default when a table is created, and they typically will use the primary key as the basis for building the index. However, that is changeable, right? We can go in there and delete the automatically created clustered index and then build a new clustered index on some other column if we choose. Nevertheless, we should strongly consider retaining primary key columns as the basis of our clustered index, because we should only change it if we have a really good reason for doing so, because primary key columns have some characteristics that are very desirable from the perspective of index. Like they're always going to have unique values in them. They're never going to have null values, right? And we're going to use them to link a table to other tables. And, the combination of all these nice characteristics, provides a lot of very strong argument for using primary key columns as the basis for constructing the index. That is, using those primary keys also as the index keys. All right. And finally, do keep in mind that, one of the considerations that we need to have in mind when we're doing indexing is, how many unique values, proportionally speaking, are there really inside of our candidate column, right? Because the kind of performance improvements that we're going to get out of an index really depend on the, kind of like the number of unique values or duplicate values in the column that we're considering indexing, right? If we have a table that contains 1 million rows of data and we want to index one of those columns, and those columns only have 3 unique values across the 1 million rows of data, yeah, we'll still get a slight performance improvement over not having an index at all, but it's not going to be much. If by contrast, we had 1 million rows of data in our table and they were all 1 million unique values, then the index would provide us with a huge performance boost in terms of our ability to find anything quickly. So the uniqueness of the values in the column matters, kind of affects the level of benefit that we get from the index.